Hey everyone, welcome back to the lab. In this video, we're going to talk about how I host side projects for $5 per month on DigitalOcean without managing servers. So hosting can make or break a side project. If it's too expensive, you're going to need to shut it down. And this is what I did when I shut down my first startup here. If it's too complex, you're going to, again, shut it down. That is if you can even, get it started. And then if it's missing capabilities that you need, then again, you'll want to shut it down, or potentially you can't even get your thing started. And so in this post, I'll share how I host side projects on DigitalOcean simply, cheaply, and with plenty of room to scale so that we don't run into these things that might break a side project. Now, quick shout out, if you want to start building with DigitalOcean, you can use my referral link here to get $200 in free credit. I'll have it linked here and also in the description of the video. Okay, how I host side projects on DigitalOcean. So I host side projects on DigitalOcean's app platform, which is DO's serverless container platform as a service offering. This provides a nice balance between simplicity, cost, and scalability. So it's very simple. I just provide, a container and it runs it, and I develop everything in containers anyway. So it's as simple as like, if it runs on my machine, it's going to run on theirs. For cost, it just costs $5 per month for the smallest box that they have. Obviously, larger boxes cost more. But the important thing here is that it's going to be a flat fee that's very reasonable for the kind of box size you're getting. And this is really important because it avoids a lot of the problems that come with unbounded costs, mainly in the form of runaway cloud costs. And there's a story here on how that kind of sunk a startup and ways to avoid it. The next is scalability. So, these things that you're paying for that runs on a small box that might feel a bit more traditional than maybe your serverless functions or whatever, typically is more scalable than the quote unquote infinitely scalable serverless functions. And the reason this is because basically we don't have to deal with all the overhead involved with orchestration and networking and stuff that is required when you move to these smaller and more distributed architectures like microservices, and then the form of serverless functions, really nano services is what we're talking about. Each of those incurs higher overhead per operation. And so when we think about scalability, it's actually typically less scalable. And so when you think of a small box, it can actually typically do way more work by itself. And it's very easy to scale vertically and horizontally because, obviously this is how we've done things for decades. And so there's really good tooling out there for making this work very simple. And so this approach works really great for me as I build most of my projects with the HAM stack, which is basically a simple Modulithic architecture. And so we're not doing this distributed nonsense. We're just doing, here's this single thing. Maybe I have a few copies of it. Maybe I have a big version of it. So running on a few small boxes is really a great fit for this. So the HAM stack itself is really an architectural pattern. But when it comes to implementation, I start most of my projects with Cloud Seed, which is a full stack F# project boilerplate, which is an implementation of this architectural pattern. You can learn more about that here. Okay, so that's kind of how I host these side projects on DigitalOcean. But I feel like there's some common questions that I get when I talk about this. And so I wanted to kind of cover those in this post as well. So the first one is, why am I choosing DigitalOcean for these side projects? So for the past several years, I've hosted my side projects on Google Cloud Run, and that's worked really well for me, allowing me to host this site for about $1 per month in 2023. And because, I've hosted my side projects on Google Cloud Run for the past several years, most of my side projects are still running on Google Cloud Run fine, because there's not really a reason to migrate them over currently. It's not urgent. It's not really important. The problem is that these low costs are highly subsidized by Google Cloud's free tiers. And, most clouds have these free tiers, and it's a really good marketing tactic because you kind of lock people in. And then when they get big, they don't want to move off of it, but now they might incur higher costs. And so this is really good for my low traffic sites because most of them can fit in the free tier. But as my projects kind of expand beyond it, like if I have one or two projects which are getting more traffic and thus breaking the free tier and moving beyond it, which they currently are, then my costs are going to increase by several magnitudes because I'm no longer covered by this blanket free tier. I now have to be paying full cost for all of this stuff. I looked around and researched several cloud offerings and started comparing, their costs. And I found that my higher traffic sites would cost me, anywhere between 2 to 10x less on DigitalOcean versus Google Cloud for the same compute offerings. And so, I'm experimenting with my options to see where I want to build in the future because, if you can lower costs there, then that means you don't need as much revenue, et cetera, et cetera. And so, I'm experimenting with DigitalOcean. I really like it. I'm moving in that direction, but it's not to say I've given up on Google Cloud or any of these other clouds that I've used in the past. This is just kind of the direction I'm going in. Okay, why not serverless native clouds like Vercel, Netlify, Railway, Flyio, etc.? And so I think there's like a lot of really great newer clouds out there, but I've mostly stayed away from them for the same reasons. And so the main reasons are that they're really kind of like true serverless. And so what they're trying to provide is like functions or nano services, or this idea that like you give them the code and you don't worry about the infrastructure it's on. And I think this is great in some ways. And it's really great that it provides, a lot of convenience. If you're there for convenience, it's great. But I think once you like open the hood and see what's kind of happening under there, and you kind of examine case studies at scale and real architectures, you start to see some very obvious issues that occur in real world apps that the kind of beautiful marketing sites hide from you. And those significant issues are that, one, it often leads to higher complexity. There are so many stories about these serverless things just breaking or going off the hinges, and the CEO needs to come in on Twitter and say, I'm sorry, offer a refund and stuff. And like, yes, there's horror stories at all clouds, but I will say for something that's supposed to be simpler, the amount of times where it ends up being broken magically is quite high. The other scalability issues, and I kind of touched this previously, is that the big lie about serverless, especially the smaller serverless functions, nano services, even microservices, is that it's more scalable. And yes, under some measurements, it's more scalable. But if we actually look at the work involved to do a single workload, it's by definition more, because we are now splitting up that one workload into many smaller workloads, each with added overhead in terms of usually networking or buffering or talking to whatever the infrastructure is. And so now this one thing that's, let's say, unit 1, by definition, must cost more. I don't know what that extra cost is. It might be 1.1, it might be 1.5, might be 2.0. I don't know. But by definition, it's higher. And so it's more scalable, I guess, in terms of the amount of throughput you might be able to get. But typically what actually happens is because you've made each workload that much higher, the extra scalability wins don't overcome the extra cost. And so you're actually typically left with a lower scalability operation overall. That's my hot take. You can fight me on this. I probably need, a better post only on this to prove myself. But that's what happens. Okay. And so, you're going to tell me, well, scalability doesn't really matter. It's not the bottleneck. True. The problem is that because we are now doing more work to get the same impact done, we now have a problem with expenses, because this convenience never comes for free. The convenience always comes with an upcharge. And this upcharge can be 2x or it can be 100x. And typically it's on the order of 100x. And so we're now doing more work to get the same thing done, and our expenses are now 10 to 100x higher for just that thing. And so, I think there's a world where this true serverless stuff that makes it super convenient is going to become more balanced in terms of costs and stuff. Like the convenience will maybe be just table stakes and it will be everywhere. And then we can just get the low costs that we get, with other ways. But currently in the current world, after looking at all these things, looking at the case studies of people using them, I do not currently believe we're in that state. And I do not believe that the trade-offs for these things are worth it. But I'm going to keep my eye on it because obviously convenience is very important. Which brings me to the next question. Why do I use serverless containers, probably versus running my own server or running serverless functions or nano services or microservices, whatever these other kind of architectures are. And I guess to clarify, I use serverless containers, but I also do moduliths on serverless containers. So why do I do this? And the reason is I'm a simple lazy person, okay? I like to do the thing correctly the first time in such a way that I do not need to bother with it in the future. Because overall, if you look at the total lifetime of a project, this typically means I get more impact for less input effort if I just do it right the first time. I eliminate rework, I eliminate firefighting. And so if I can get 80% of the impact for 20% of the costs, I want to do that. And so this is why I seek out Simple Scalable Systems. And this is basically what this whole channel is about, is me trying to do the thing. I see what doesn't work. I find a simple way to do most of what I want. And then that's what I write about here, because I want to remember that and reuse that in the future. And I like these because they basically allow me to do things better for less effort, and thus allow me to be simpler and lazier in my life, which is, my default and what I bias towards. And so serverless containers are a simple scalable system for modern deployments. They provide a nice balance, again, between simplicity. I just provide the container and then you run it somewhere. And again, this is good for deployments because I'm running my dev things in containers. So it's very easy to just send it to prod with limited changes and it'll work, especially on Moduliths where you only have like 1 or 2 containers to worry about. It's also very highly scalable, right? So it typically is going to run on normal boxes, which makes it easy to scale horizontally and vertically. It's going to be cheaper for sustained traffic levels, especially compared to, again, serverless functions, nano services, because the workload cost is just 1 unit versus the explosive 1.52 units. And because we're running on just normal boxes, it's typically way cheaper than having to incur the convenience costs of the overhead of whatever extra stuff they're charging you for the convenience. And it's often just simpler to understand. When we're doing this, we're usually working in a mono repo, which is typically just simpler at scale. We only have 1 or 2 deployments, which is just going to be way simpler than 50 or 100 you're going to have in nano services. And so we're really scaling for the human element, which is almost always the actual bottleneck in sufficiently large software architectures. And the last is that this is systemic, right? So most clouds support serverless containers natively. They basically all can be you give me a container and I'll run it. And even those that don't can usually be modified pretty simply to do so. So, as long as they give you the ability to run a server, you can just load up Docker on there. You can use all those other things that will do it for you. And then you just give it the container and run it. And this works both, at low and high scale, right? If I have 1 box, I can do this. If I have 100 boxes, I can do this by building a bash script or something. And because it's just a container and you can run anything in containers, it really works for basically any kind of stack or operation that you're trying to run. And so this makes it systemic and reproducible. And that's good because you can learn how to do this well, and you can basically use it to power, most of the things you're trying to do. And so, these are the reasons why I like serverless containers, why I bias towards things that make this very easy. And I'll probably be sticking with this until I find, a better approach somewhere down the road. Next. So overall, I really like DO. I think it's much simpler than Google Cloud, especially with all the permissioning stuff Google Cloud has on them. I'm sure for big enterprise, it makes sense, but oh my gosh, it's some arcane logic to set up the right things in order to actually get your thing deploying. DO is much, much simpler than that. And basically it provides the same power, right? All I'm asking for is the tiniest box you got, make it cheap, run my thing. That's all I want. And it's just much simpler to do that. And, it's capping my expenses at $5 per month, which is a great way to avoid runaway cloud costs. So, I have a higher fixed cost for small projects, but I'm not going to get the $100,000 cloud bill accidentally that these guys did here. That said, it is a bit more expensive than Cloud Run for my small projects that fit in the free tier because it's not subsidized. I do have that higher fixed cost. So, a side project that gets 0 traffic should cost me $0, but here, if I'm running it here, it would cost $5. But I do think it's a reasonable trade-off for now. $5 is a cup of coffee, and if I won't buy my project a coffee, then maybe it's time to shut it down. And I certainly feel like $5 is a good insurance mechanism to not pay $1,000 because I got DDoSed or something. So probably a decent trade-off. That said, I've got my eye on Coolify and some of these other guys. There's some older ones like Dockerize and stuff like that, which basically allow you to add serverless functionality on top of servers that you rent. And because servers that you rent are typically much more powerful for much cheaper, you can actually typically run 5 or 10 projects on the same box, especially if they're dumb little projects like mine, which get no traffic. And so that would let me, probably rent bigger boxes for cheaper and host my projects for basically the same complexity level, which I think is probably what I want to do long term. But I just haven't tried this one out yet, and it's still kind of in development. So I'll keep my eye on it, but haven't moved there yet. So if you like this post, you might also like techniques for fast, cheap app building and 3 areas I'm exploring to build more side projects faster and cheaper in 2024. You might also be interested in my app building philosophy and the HAM stack, which is a simple scalable tech stack for building modern web apps fast and cheap. And finally, you might be interested in the project boilerplate I use to start every project, and you can learn how it works in Cloud Seed Quick Start, a full stack F# app in 10 minutes. So that's it for this video. Thanks for watching, and I'll see you in the next one.